Hi, Andrew, you made it. Thank you for
Good
getting
morning.
involved.
Sorry, I don't have Zoom installed, so it was
Apologies. No, I'm glad you made it. I'm very glad you made it. We're just about to get started.
All started.
So, gents, I can see around 35, 36, 39 now. So, with people joining, I'll just give people a moment to get settled in. Good morning, folks. How are we doing, Virginia? I can see, I think, is that 55 now on?
Yes. Yeah. I
Okay.
think they're done loading.
Okay, great. So, welcome, and thank you for joining us this morning. We're here today to finally launch the GWO high voltage standard. So the standard was officially published yesterday on the website. So July 2nd, the standard has gone live, and we have a release webinar for the next hour this morning, and we have a second webinar planned July 23rd from 3 o'clock to 4 o'clock for anybody in a different time zone. At that point, we'll do the same format, the same presentation that we're doing today. So with me joining the session, I have two Andrews. So first of all, myself, I'm Thomas Redmond, training project manager with the Global Wind Organization, and I have been the lead project manager for this high voltage development project, which we've been doing for more than a year. And my role has been to coordinate with all of the GWO member experts in the development of the standard. And then we have a couple of our high voltage specialists that have been a part of the development from our member companies with us today. So Andrew James Cofield from Vestas. Good morning, Andrew.
Good morning, everyone.
And Andrew was with us, from the early days of development. So he's been through lots of workshops and eventually piloting and the final release of the standard. He's been there all the way through. And then we also have Andrew Redfern from Siemens Gamesa, who supported us during our testing pilots at the final proofing and validation of the standards when we did that in the UK recently before final release. So also good morning to you, Andrew.
good morning, everyone.
So yes, everybody that's here on the call, the format for the session is to take you through a bit of an overview of the high voltage standard and the two modules within the standard, which is the high voltage operations module and the high voltage cable pulling module. And then there's a few things which I've just highlighted, which I think people will be interested to have specific information about. So we'll give some particular information about the target audience for these modules, a little bit of discussion around the facilities and equipment for a training provider to deliver the training, a highlight of the instructor profile for these modules. We'll provide some information about where you access the standards, and there's also some more information you can access in our help center. And we'll wrap up the session with a Q&A session. So in the Q&A session, you'll have an opportunity to ask questions. You can type questions into the questions and answers function. So there should be a button somewhere where you can type in, and we'll tackle those during the Q&A session. You can also, during the Q&A session, you can also raise your hand and we can open the microphones and you can kind of provide a question verbally. As we're going through, if you have a question, take a note of it and we'll try to tackle it in that Q&A session at the end. So we'll leave plenty of time for that Q&A. So just to get started, where has this training standard come from? All the way back last year, as early as April, we, as GWO, were asked by our members to investigate training for high voltage work, and that can include a lot of different things. So we did a broad analysis, which resulted in identifying some areas to focus on, and then we did a design and development, and finally piloting That included a public hearing to get feedback from the public and eventually the publication of a standard. This has all been totally driven and developed by the member. And so you can see here the logos of some of the member companies that actually supported us with expertise. So Cubico, Enercon, NG, GE, Northland Power, Nordex, Ørsted, RWE, Siemens, SSE, Investas. We had a very big work group working on this project. And so in the project, I've had high voltage subject matter experts, more than one, sometimes two, three, and even more from some of the member companies representing each of, you can see here. And then on top of that, when we finally publish the standard, it gets reviewed and approved by the GWO Training Committee and Board of Directors, which is made up of all of the representing all the GWO members. So we're hoping that this standard represents the industry really well and what the industry needs. Part of the development process is a public hearing, which took place a number of months ago. This was a standard with a lot of interest. We had a lot of downloads of the standard all over the world. You can see kind of some of the statistics here. And you can see the feedback ratings that we got, very positive overall. And this was before the pilots. We pilot after this period and we make some final tweaks before we publish. But again, this is just a sign that this is a training topic with a lot of interest. And we're hoping that this will be something that gets a lot of use now that it's been launched. So what do we have? We have the GWO, the high voltage standard. And within the standard, we have, at the moment, we have two modules, high voltage operations and high voltage cable pulling. So these are two very distinct modules for two different target training groups. High voltage operations is a training for the safe operation of high voltage equipment and systems. It's very much an electrical program. High voltage cable pulling is training for the effective pulling of the power cable in the tower. So HV cable pulling operations, which could take place during pre-installation, could take place on site during construction, and could also take place during service, switching out of a cable. And so the profile for that is a different profile, and that's a very hands-on training, handling cables, inspecting breakouts. So it's certainly a high voltage specialist area in some senses, but it's not an electrical focused program in the same way that HV operations. So we have two distinct modules at the moment here in the standard, and we'll just make sure that those are clear. So just to give some information in detail about the HV operations. So we have a 28-hour program. So it's approximately 4 days duration. There's different ways that you could divide that up as a training provider in 28 hours. But you have 28 hours duration. We have a heavy focus on practical and practicing skills, as well as building up the base level knowledge. So there's roughly 70% practical in there over those 28 hours, but that's blended together with lots of basic knowledge, skills, and especially abilities, behaviors to do work safely. It's been designed for a maximum of 8 participants, where you would have a maximum of 4 under supervision of 1 instructor in the practical at a time. And so that's roughly a 28-hour program for 8 participants. So you're talking 4 days or 3.5 into 4 days certainly, but in terms of time, maybe 3.5 if you were to really pack the hours in. The certification is enduring. So this is an introductory training. It doesn't have an expiry. The idea would be that you complete this training, you go back to the workplace to continue with your company-specific, site-specific development and training, learn about the specific equipment that you use in your workplace, and continue in your development towards an authorized person in the workplace through experience. And for that reason, this is an enduring qualification. You don't come back to refresh this introductory type training. Of course, you do refresh your training and skills once you're qualified and authorized to carry out work, but this introductory training is designed as an enduring qualification. You can see the lessons listed here, 1 to 16. So we always have an introduction and a review session. So really there's 15 core lessons in the standard, in the module. You can see them here, opening up with human factors and safety mindset, which is a big focus of this type of training. We go into wind farm high voltage systems and equipment, hazards and risks awareness, safety and control measures for the HV environment, and regulation standards and guidelines. Then we move into safe systems of work, duties, roles, and responsibilities, familiarization with the correct tools and PPE for high voltage work, the fundamentals for operating HV systems under a safe system of work. And then I would say from where you see 11, 12, 13, and 14, you have some very substantial practical sessions, high voltage switching, scenario-based practical activities, where you're practicing communications, identifying equipment, carrying out switching operations, different scenario-based activities, using your tools and equipment to confirm absence of voltage, applying isolations and earths, and maintaining safe control of equipment during any kind of activity, including testing. And it does include, as part of the final assessment, a formal written knowledge assessment, which takes place after you have completed your practice and built up all your core knowledge. So that's the structure overview of the program, 28 hours. Some training providers may choose to use some e-learning for some of those hours, as kind of a pre-learning or a baseline kind of building of some of the knowledge. But based on the practical, I think most training providers would certainly, even with some e-learning, be looking at 3 days practical in the training center, even with a bit of maybe some of the hours being covered by e-learning, but that's an option too. So 28 hours duration overall, heavy focus on practical, lots of practical activity in there. And you can see in the image during pilot some of the kind of activity you might be engaged in. So a couple of questions I thought I would just flag at this point. So high voltage operations. One of the things to be very clear about, completion of this training alone does not deem participants competent to perform high voltage operations in the workplace. So this is something that has come up during our public hearing as a question, and it's something we wanted to make clear. So in the standard, this is quite clearly stated. This is an introductory training. It's a generic training. It can only be so specific because there's a lot of different ways of working and equipment that you work with in the work environment. And so completion of this training gives you that base level knowledge. But after this training, you return to the workplace and you start to build experience. In the standard itself, we have a template for a experiential logbook, but most often this is something your employer provides you in your workplace. And so after your initial training, you would be expected to return to work, be trained in the specific equipment and procedures that you use in the workplace, and then go on to build up your experience and log your experience. And so your company then would take responsibility, the duty holder for the site, to determine when you're ready to become authorized. And I might just open up this point to the guys that we have on board. So from Siemens' perspective, Andrew, what would the path to authorization look like for somebody that does this training? What would happen next? Where would this training fit into your HV technician profile?
So we would identify potential individuals that will be ready for completing authorized training. So then we would, once they've been valued and identified, they would then go onto this course to gain that extra knowledge. And once completion of this course and they've come back and they've passed and they've gained a substantial knowledge from the course, they would then come into our in-house authorization training, where we would make them knowledgeable within our own company electrical safety roles.
Great. And I suppose for different individuals, that could look a bit different in terms of building up the experience, because some may have less experience, some may have more experience coming from different backgrounds.
Yeah, and that would be part of our evaluation when we're looking at the individuals for authorization.
Fantastic. And from the perspective of Vestas, Andrew, other Andrew, from the Vestas perspective, what would that look like?
Yeah, this would form part of our basic training to allow people to switch. So I think as Andrew said there, that once they'd done this training, they would have the training in-house within specific equipment that we have, familiarization with equipment that we use, and then form onto an authorization panel. Again, looking at experience as well on top of this. But this forms a big part for us investors of what we would the proficiency would need to be able to carry out HV switching.
Yeah. So this is a substantial part of that initial training. There will be some add-on that's always needed, but it will be much smaller than it used to be with this training available.
Yeah, that's the plan.
Brilliant. Okay, so we just wanted to make that clear. This is a very high hazard activity. And so we need to make sure the risk is controlled, and we want to make sure that nobody is going back to work thinking that they're ready to take on activity until they truly are ready. And so that kind of process is important. After initial training, becoming familiar with the workplace. Yeah, okay, sorry, this is the same point. I just put it up in black and white. This is part of our frequently asked questions in our help center on the website. We have some of these questions documented with these answers. So the question of, does completing this training mean a participant is authorized to perform HV switching? The answer to that is no. Participants have a base level of competence. They have the awareness to go back to the workplace ready for that site-specific, company-specific training to kind of get on that path to authorization. And how long that path is very dependent on the individual and the company and the situation that you're in yourself. So yeah, this is forming a substantial part of that preparation, and the final stuff happens on location. Okay, cable pulling. So just to give a overview of the content and the structure of the HV cable pulling. So this is our second module within the standard. The HV cable pulling module is a one-day training. It's 7.5 hours. It's designed for up to 12 participants. The ratio between the instructor and the participants during practical sessions is 6:1. It's a very hands-on training. The certification is also enduring. So this one does not expire either. It's an introduction to handling cable, pulling of cable, inspecting of the breakout. It's a very practical, as I say, training with approximately, well, more than 70% practical, I would say, in this one as well. You can see the lessons listed here. So again, we have an introductory and a review lesson in the module. So you can see it opens up with an awareness of HV cable theory. That is just a basic awareness, so the profile for this participant is not an electrician. These are the crews of workers that are handling the heavy HV cables, MV and HV cables, power cables in the tower. And so some of those may be electricians, but that's not necessarily the profile. So there's a little bit of basic awareness of the properties of the cable. There's a substantial focus on breakout inspection. So the breakout is where we have the conductors split in the end of the cable where it's terminated into the equipment. And so there's a substantial focus on making sure that we know how to inspect that element of the cable before we conduct a cable pulling operation. Cable inspection itself, looking for good and bad signs of any damage to the cable. Safe work during the pulling operation. Preparation of the cable and tools, handling of the HV cable to avoid damage to the cable primarily, as well as to do it safely for manual handling and for the team. Conducting the cable pulling operation and completing the cable pull, where a cable would be pulled into place, secured, cleated or clamped securely. And if that was onshore, a tower might be going offshore with a cable in place, or indeed, if it's already on site, it may be remaining in place until a commissioning team come along to terminate a power cable into pieces of equipment. So we have a one-day training, a lot of practical again, and a different profile dealing with the high voltage or medium voltage power cables in the tower. So a question again, why is the standard divided into two modules? Well, we have two quite distinct trainings. We have a training for high voltage operations. So this again is for personnel who are operating high voltage systems. So they're switching, earthing, isolating to manage the system safety. The HV cable pulling is for technicians involved in the inspection and installation of the power cable in the tower. So the HV or MV power cables during pre-assembly and during site-based operations. So do participants need to complete both HV modules? No is most likely the answer. It is probably different profiles of worker that would attend these trainings. Now, there may be some workers that would be involved in both these operations, but certainly the expectation is not that you do one and do the other. They're not connected in that way. So they're two distinct trainings. They're dealing with different competencies, and you would have most likely a separate group of workers that are doing these jobs. And in fact, during the cable pulling operation, especially in pre-assembly, for example, there wouldn't be any electricity, any live HV voltages present. So there wouldn't be switching operations happening until you have a live plant. Now, during a site operation where we're switching out a cable, this is a situation where that would be a bit different. We could in that case be making a system safe before we're dealing with a cable pulling operation. I mean, I'll go back to the guys from your perspective, either Siemens or Vestas. Would you envision it being likely there'd be many workers that would be trained in both these profiles?
Probably not, Thomas. I think one is about the operation of electrical high voltage switch gear, and the other one's about the setting up of the connections for that equipment, and that's usually done when the system's de-energized.
Yep.
So there's no power on the system when we're doing this. I think the cable connection one is interesting, because I think that becomes the midpoint between connecting the cable and then energization after that, and I think that's where the two meet, if you like.
Yeah, that final inspection of the breakout area.
Yeah.
And I think it's probably the same from your perspective in Siemens, Andrew.
Yeah, to an extent. I mean, I could see the value of it still being used by authorized technicians if they're going out, maybe for an nacelle removal or any sort of involvement where the cable needs to be removed, lowered down, and then pulled back up. It might be of use. I still see its value potential. So it just depends on the task and how the technicians are going to be mobilized or used within that sort of industry or scope.
Yeah. Okay. And so
I think the big value, Thomas, is for contractors. I mean, both of our companies use a lot of contractors in installation. So having a standardized course for that, I think helps both of our companies. If a contractor comes along and our guys have had this training in cable pulling, or we can say, well, that's a box ticked off. We know it's standardized then. I think that makes a big difference.
And it's something that we've made a big effort with both of the modules with this standard to make it generic, so that especially contractors can do this training and they can go to different operator sites and dovetail into the way that you work without finding something dramatically different and without having a only one way of doing things explained to them before. So again, the idea of generic training to support people in different locations. So we have two modules. And they're separate, so they can be done separately and individually, and some profiles may be doing both of these trainings depending on the work that they're going to undertake. So just to visualize what that looks like, the intended kind of general target audience for HV operations is broadly speaking, commissioning and service technicians, and for the cable pulling, pre-assembly, installation, and some service technicians. But that's not to say that that's always going to be the case, but that's the kind of broad strokes of the target audience. So this target audience, the training prerequisites, what is the profile of the of the learners coming into these programs? So for HV operations, we have written this into the standard. The participants must possess underpinning knowledge, skills, and abilities in safe, low voltage electrical working. So moving into high voltage training is a progression from safe low voltage working. They must have the capability to perform tasks while exposed to low voltage hazards and risks, and have electrical workplace experience to be technically capable to participate and succeed in the training. They must have completed the GWO basic technical training electrical, the COE electrical, or an equivalent to those trainings. So it's not a black and white requirement. It's not mandatory that you must do BTT electrical and you must do GWO COE electrical, but you must have the equivalent. You must either have those or an equivalent training. So that means you have your underpinning skills and knowledge for electrical work, and your like lockout, tagout, isolation, safe isolation practice training as well. So that might be company specific. It may be different in different regions. I might invite, the guy. Oh, apologies. I might invite the guys again just to comment here from the perspective of say from Vestas perspective. What would be the kind of typical profile of somebody coming into this training that you would expect?
From a perspective, we have two different safe systems of work offshore and onshore investors, but offshore we use WTSR. We do use this onshore in the UK as well, but WTSR and AET would be sort of like the level. An authorized technician, low voltage WTSR would be a level. And under our other safe system of work, Lotto, that would be somebody that a Lotto level 2, which would be trained in electrical safety for qualified persons. That would be the sort of level we were looking at for that. So it's not somebody that's walked off the street. They have to have some experience of working with electrical items.
Yeah.
Electrically skilled, could be said, electricians obviously as well. So that would be the sort of level we were looking at.
You mentioned WTSR, that's the wind turbine safety rules
Yep.
from the Energy Institute and Renewable UK as they were originally designed, which would be something equivalent to doing a COE type training for safe working and isolation in low voltage work, right?
That's correct. Yep. Sorry, I have a dog that wants to join.
That's okay.
And I apologise for that.
That's okay. And what about from the Siemens perspective, Andrew? What would be the kind of target audience profile that you would expect?
So from within our company, our technicians would have the high voltage technician profile for offshore.
Mm-hmm.
They would have already gone through and had their past knowledge and experience and qualifications assessed to deem them to be able to fit that profile. So they would all potentially be electricians. They'll have electrical qualifications, industry experience, to be able to advance into this course.
Yeah. And I can also say that in some regions, the requirements as prerequisites may be higher because of local compliance issues. So I know in Germany, for example, we've been provided feedback that in Germany, you may have to have a specific electrical profile in order to attend this type of training. It may be different in Poland. It may be slightly different in the US and other regions. And so the training is designed to be flexible to allow it to be adapted for different regions. But training providers will have to ensure that they're complying with their local, whatever the local compliance issues may be in their region. So if a region if the local regulations say that you must have a vocational training as an electrician, for example, then that would be something that the local training provider would need to apply. So we've set the bar at the minimum level, and locally you have to adapt to the regional requirements where you operate, or potentially deliver your client requirements if your client is asking you to deal with their own particular way of working as well. Okay, so the same topic on the HV cable pulling. So for this cable pulling training, participants must possess underpinning knowledge, skills, and abilities in mechanical work, and they have an awareness of safe lifting operations to succeed in the training. So during a cable pulling operation, there's a hoist, maybe a chain hoist being used. This is not a lifting operations training. So if you were responsible for the operation of the hoist, that would be a separate training. But the crew themselves would be handling some of the lifting equipment, and they'd be interacting with that lifting operation quite closely. And so having an awareness is important, even though there may be somebody dedicated to the lifting responsible person role during the operation. They must have completed BTT mechanical or an equivalent local training. Again, we're not saying you must have only the GWO BTT mechanical, but you must have the same level of basic mechanical skills that you would get from that training. So you could do the BTT mechanical, or you could have done a local equivalent training. Familiarity with lifting principles is really strongly recommended. And so the GWO Slinger Signaler provides that type of familiarity. Crane and hoist operator provides some of that similar familiarity, but those are not mandatory prerequisites. The focus on this training is on the team that are handling the cable, inspecting the cable, fitting the cable sock, dealing with the operation. And as I say, the lifting responsible role would be something that needs additional training for that person that's taken that kind of particular responsibility. Mechanical skills are important for this one in terms of handling tools and equipment for securing the cable and working with the cable movement operation. In terms of the profile for this one, from Siemens, I know that the Siemens team really have an interest in this one for pre-assembly technicians and others as well. Andrew, what would be the kind of profile of your typical cable pulling team, or the lead, let's say, maybe on the team?
For the team in general, I would expect them to have some base mechanical knowledge. It might be from past experience, working in industry on different sites, different might be power stations or similar, and for them to be able to understand and have the appreciation of what's involved in the cable pull and how they can conduct the cable pull safely and from a quality perspective, inspecting the cable and doing it and completing it safely. And then for the team lead, we would expect them to have some experience from previous projects or previous tasks of doing this job. So as long as they have an overall sort of experience, and then they can go to this course, they can get the knowledge from the course, the understanding from the course in how the cable pull will be prepared, carried out, completed, inspections before and after, and fitting of the cable sock. So as long as they can sort of have evidence of that and they can demonstrate that, then I think that would be sufficient.
Mm-hmm. And I would say that this cable pulling has a big focus on quality of the operation. So particularly on making sure that we do not damage the cable, that we appropriately inspect the cable before pulling it, so that you're not finishing an operation and then discovering damage. Safety is a big part of it. It's a hazardous operation, so safety is of course a big part of the training. But this one I would say is very much quality training on improving the quality and effectiveness of that cable pulling operation.
Yeah, that's right. To be able to understand in how the cable is going to react and the size of the cable, the bending radius, and how you can facilitate that without damaging the cable and getting it into the position where it needs to be on the cable run. So in order to complete that course, they will gain all that knowledge to then use on site to make it more efficient from safety and the quality aspect.
Great. Okay, I'm going to move on to the next slide. So from training providers' perspective, if you're interested in setting up training, the question is going to be, what do I need to set up this training? So in terms of facilities and equipment, for the high voltage operations training, I would say that you would expect to see a substantial facility to be able to conduct this training. There will be lots of providers out there that already have high voltage switching training within their facilities. It may not be, of course, at the moment, GWO. And there may be other providers out there in the world who are not yet GWO providers, but who already do this training. There are lots of providers of this type of training for the wind industry and lots of other industries as well. You can see some images here. So we were supported in our piloting of the program by Relion in the UK and by Maersk in Denmark. Both had fantastic facilities that they provided for us to use during the piloting process. You can see the images here from Relion in Redcar in the UK. So the facilities as a minimum for this program must include high voltage switchgear with the features and functions of an operational system. It must include the most basic features of circuit breaker, disconnector, and earth switch. And then when you look at the scenarios and exercises in the program, there are lots of elements there that you want to be able to practice. And so you should be able to practice those on your equipment or with elements being simulated alongside the kind of, let's say, the main piece of equipment that you're using. An example of that may be carrying out earthing exercises on a physical transformer or some sort of a physical simulation of a transformer. You can see in some of these images that happening. But certainly you would need at least one suitable example of switchgear with those features. You may not have all the features built into your piece of equipment. You may have a piece of air-insulated switchgear. You may want to illustrate gas-insulated switchgear. And so you have another way of illustrating the gas reading pressure gauge on the equipment through a different piece of simulated equipment. In some training centers, you may have, in most training centers, I would say, you will not have high voltage supplied to the training equipment. It's not required to have that. It's most often simulated high voltage with the equipment functioning just with a low voltage setup, but functioning realistically. However, you could have high voltage, and this could be training that you did with operational equipment at site, which would be more complex, a lot more work involved in organizing that, but it is an option as well. From your perspective, I'll go to Vestas. Andrew, from your perspective, what would you advise on training equipment for providers?
I think it's essential to have a physical switchgear, at least to be able to demonstrate the function of it. I know there's a lot of e-learning and stuff out there, but there's nothing the same for a technician as getting their hands on the equipment and actually seeing how that works in practice. And the tools as well that you have to use with the switchgear to enable. It's not just a switch, if you like. There's we have bars for disconnecting and earthing, etc. And also the verification of absence of voltage and the portable earthing equipment. There's all of these separate things that have to be accounted for. So physically having a switchgear, I think, is quite important.
And that switchgear, I mean, the switching is an activity that involves a lot of teamwork and communications and protocols between different parties that are working together. And so that's a big part of this as well, being able to have the team that are conducting the operation work together, follow instructions, communicate, and carry out the operation in a realistic way.
Yeah, I think what we've seen at the Relion pilot was that there was a communication chain. There's also remote switching, which is the safest way to do it as well. And that was actually demonstrated, the setup they had there. That could be something that features as well. It's obviously safer to remote switch and not stand in front of the switchgear in real life. But I think the communication part was really important within the training. It showed how it was controlled. It wasn't just somebody going up, flipping a switch. It doesn't work like that.
Mm-hmm. And of course, as you say, along with the main piece of equipment that we're working on, we have PPE, we have tools, and we have other things as well, protocols, radios for communicating and different means of communication, documents and paperwork, and the environment itself where we're simulating a work environment. So in the standard, we have an annex. The equipment annex specifies the required equipment. It's open and flexible to different setups, but it is quite clear. You do need, at minimum, a piece of realistic physical equipment. Some of the functions and features may be simulated in different ways. You may simulate, most likely, the high voltage itself and have it running on a low voltage kind of setup. And you may not have every function and feature that you would want to train in the scenarios. So you may have different ways of illustrating different functions and features, but there is a basic level there that you will need to make this kind of an effective training. On to the cable pulling facilities. So training facilities and equipment, again, must provide a chance to do some realistic hands-on practice in different key skills. So the handling of the HV cable, the use of the tools and accessories that you would use during a pulling operation, protection of the cable from stress and mechanical damage, so applying protection to handle and move the cable, and particularly inspecting the HV cable and the cable breakout. And so typically what you would need here, again, we have a specification in the equipment annex. You're going to need a minimum length of high voltage cable so that you can fit a cable sock. You will need the physical cable sock, ideally multiple examples. There are different types of cable sock. You do not need to physically pull a cable, that would require, quite a length of cable, and it's a big operation to pull a cable. So it's not about actually simulating the full pulling operation, but definitely you do need to be able to practice fitting a cable sock, practice inspecting lengths of cable, practice physically handling cable, and get a feel for what that's like working as a team, using some of the tools and accessories for directing and moving a cable, rollers and protection. And particularly, you certainly need examples of good and bad cable breakouts where you have faults or small pieces of damage which the learners need to identify. From the Siemens perspective, Andrew, you got a chance to see this in the Wind Academy in the Port of Blyth. We had a pilot there. You can see some images. I think in these images, we're looking at the other pilot that we did in Denmark, at Delpro with Maersk and Delpro. But from your perspective, Andrew, what's quite critical about the equipment here for this training?
I think there's real value in the equipment being available that you can simulate as close as possible as what they will experience on site. So having the length of cable there, having the cable socks, different variations in cable socks, examples of breakouts, example of good and bad, like you said, cable equipment, and being able to physically get onto the equipment, being able to have that communication within a team, setting up the area safely, having a work area, a perimeter, so you can organize it correctly, laying out a carpet for protection, bringing the cable out, doing the cable inspection, and sewing the cable sock on correctly, so you can all be prepared for the cable pull.
Fantastic. And as we say, in the standard, we have a specification of tools and equipment at the back end in the annex. And any questions about that are welcome. So finally, a little bit of information about the instructor profiles. Again, just making a clear distinction. There is a difference between the instructor profile for HV operations and HV cable pulling. We would love for you to have fantastic multi-skilled instructors that can cover everything. But in the standard, we have provided a specification for the instructor profile. And this is just a copy and paste. So you can read this in the standard in black and white. The HV operations instructor profile is described here. So they must have experience and qualifications in HV operations to be able to ensure all the learning activities are carried out in accordance with current legislation and industry standards and good practice. They must be able to demonstrate knowledge, skills, and abilities in safe HV operations comparable to those executed by the participants. So really everything that's in the standard, the instructor has to be very familiar with. They have to be able to teach everything that's in there in terms of all the scenarios and skills and exercises based on their knowledge and experience that they've built up in their past. It's a fairly open way of describing the profile, but it is quite clear that they do need this specific background, knowledge, and skills to be able to deliver the program. In addition, they must be in part of an ongoing development program to be able to maintain and update their skills and knowledge with the changes of technology and working practices in the wind industry. These are things which, as a training provider, you would need to manage and handle, and these are not really so different than the basic requirements for training. So in your general requirements for training, you have these core elements which all your instructors need to achieve. They need to be able to deliver the programs. They need to have the basic underpinning knowledge and skills as per the standard, and they need to be included in ongoing development. But for this particular standard, we have made this black and white by putting it in the particular standard. So this is a reflection of the requirements for training, and it also is just a reflection of the kind of high level of capability of the instructor profile. You can see a similar wording for the HV cable pulling operations. Again, particularly focused on the background skills and knowledge to be able to lead the learners through the program. I would say for the cable pulling, it is very important that your instructor is familiar with the inspection of the breakout, which is quite a technical task. The learners themselves are not going to be experts in inspection of a breakout. They are going to be able to recognize problems and flag those problems to somebody more competent, more capable than them to make decisions about what to do next. But your instructor certainly is going to have a strong knowledge so that they can properly teach this part of the program as well as all the other parts as well. Again, this is a reflection of the requirements for training, but it's quite specific in the standard. So it's important that you do have a look at that section for both those modules. So before we get to the Q&A, where can you find the documents? So on the website, you have a publication section and you have the help center. You can see them highlighted orange. In the publication section, you will find the standard, and in the help center, you will find frequently asked questions. So the HV standard is live on the website, published yesterday. You can download it there, contains both modules. And in the frequently asked questions section of the website, the help center, you find the frequently asked questions. So click into training standards and you'll find a lot of the stuff we've covered today in the frequently asked questions for HV, and there'll be more as well. There's some more stuff in there as well. You can also submit questions through Zendesk or by email. So you can email, apologies, I can see a typo in our email here. That's my fault, but info@globalwindorganization.org is our info email, or you can go through Zendesk through the inquiries page. So at this point, I'll invite questions and hopefully we can tackle them. So I'm going to need a little bit of support from Virginia in this. We have,
Yes,
I can
of
see,
course. You
we
have a
can-
few questions actually.
Okay.
And I would say that you start with, there's quite a few misunderstandings regarding training equivalents. So there's one that says 5.7 in the standard, they must have completed training equivalent to GWO, BTT electrical and GWO GWO electrical. They must have completed training equivalent to GWO, BTT mechanical. Does the word equivalent mean we have to become GWO recognition providers or follow the GWO recognition process?
No, it does not mean that. So we are trying to ensure that there's access to this training in as many regions as possible, even in regions where those particular GWO programs are not available yet. So one solution is that somebody has the particular modules we mentioned, for example, BTT electrical or COE electrical, but a training provider is free to accept students who have an equivalent training. What is an equivalent training? It is a training that has the same level of knowledge and skills and abilities. So that's a task, a challenging task, but that's a task for training providers to make that assessment, to accept somebody onto the training.
So there's a follow-up question, and I think it's just to drive that point really well. Who should verify the equivalent local training before joining HV training? Is this prerequisite mandatory or recommended?
It is the task of the training provider. So when you have this approval on scope and you have a strong, full understanding of the HV standard, because you have it on scope, you're now qualified to deliver it, you will be capable of reviewing the entry point for your participants. And so that's something that you're free to do. Once you're accredited, you're being given the trust to review the underpinning knowledge and skills of the training of somebody coming onto the program. The easiest, most clear answer is that they have the GWO modules, but if they're not available, you've got the option of looking at their existing training. And of course, then they still need to pass the course. They still need to come on, do the training, pass the assessment to be able to succeed in the training. So it's in their interest to be coming on the program with the right background so that they succeed and they don't fail the program.
Perfect. Okay, so there's 2 questions from Jesper. Will the HV operational training be conducted on dead or energized equipment, using real equipment or via virtual equipment in the training facilities?
So dead in the sense that the equipment has no power whatsoever. In some situations, that's part of the training itself. So you may be applying an isolation to the equipment is the exercise. I think in most situations, the equipment will not be supplied with high voltages at all. That will be simulated as part of the equipment setup. In some training providers, you may have high voltage available, in which case a much, let's say, higher level of kind of thought and control and planning would have to go into place. So it's an option to have real operational equipment. It's probably unlikely because there's a lot of work involved in that. Most likely it will be physical equipment with low voltages supplied so that the functions and readings and things will react realistically. And then the physical training, the training on physical equipment can be complemented with other simulated systems. So virtual systems, augmented reality, virtual reality. There are lots of HV training simulators that have a physical, kind of a simulated physical switch with a screen which gives you other functions and features, remote switching, umbilical switching, communications functions, and different readings and functions. And all of that is quite acceptable as long as you do have that kind of physical piece of equipment for really doing the practical elements. And so in the annex to the standard, if you look at the back end, there is an annex there which describes this in quite a bit of detail in the description of the training equipment, which includes a piece there about voltages and also about simulation and about virtual reality as well.
Also from Jesper, is the training primarily focused on wind turbine HV switch gear, or does the training also reflect OSS HV equipment?
OSS, I'm assuming this is maybe offshore substation, OSS. So I would say that the training primarily focuses on, and I'll invite the guys in to interject here as well. The training primarily focuses on single feed, simple switching operations. So single feed where we have power coming in, power going out from a wind turbine, more than switching in a substation environment where we have a more complex operational environment. Now, is the training suitable for somebody working in a substation environment? Yes, it's a basic introductory training, but they're going to need to do a lot more to get to the point that they're able to be deemed competent and authorized after the training. The scenarios in the training focus on simple operations. It's an introductory training. There is some scope to do more complex things. So I'm not certain if that's answered the question. I'll invite either of the guys if they have a comment on that one.
I think that the training is mostly based on single feed switching, Thomas. It's not for multi-feed switching. That's more complex than something like an SAP level would have to do. So this is set for AP level, really for single feed switching.
Yeah, well, there you go. So we're getting somebody hopefully up to the point where they're returned to the workplace on the path to an authorized person rather than that more complex level. So hopefully that's answered the question. But again, if not, feel free to drop us a question by email.
Yeah, I think there's a few that are very compliance focused that I would encourage them to write directly to info@globalwindsafety. And then there's one more question from Sean. One, BTT installation module have the cable work, like cutting and crimping cable, hence the HVCP training. It is for MV and HV cable connection only. Any same learning objectives between BTT-I and HVCP?
Yes, okay. So the question is there a significant overlap between a BTT installation and a high voltage cable pulling? Because in the BTT installation, there's some topics there covering cable work, installation cable work. I would say there is a minimal overlap. The BTT installation it does include, termination of cables, crimping of cable and connections, and dealing with that type of work. The HV cable pulling does not deal with that. So you're not dealing with making a termination of the cable. We're talking about large power delivery cables. So the HV cable pulling has some overlap in terms of handling the cable, but the scale, dimensions, and difficulty of handling these large power cables is different than the smaller kind of work that we're talking about in general in the BTT installation. Okay.
And there's further questions here about local standards and like local regulations. So Thomas, why do we not list local regulations, and what are the standards locally in our standard generally?
So we do list a couple in this particular standard. When we were doing this work, we primarily focused on NFPA 70E, which is American, and we focused on EN 50110, the European norm. What we did is make sure that the training was not coming into conflict with these standards. It's impossible to write a training, let's say, that is aligned with every legislation globally, because everything is slightly different in how they describe a particular role, a particular responsibility, a particular way of working. But we looked at EN 50110, NF70E, NFPA 70E, and we made sure that we didn't come into conflict with those. We also looked at G+ safety guidance, and lots of other things as well. If you have a look in the back annex of the standard, you will find a list of those references, and you will find statements there about how we've tried to avoid any issues of compliance in different regions. It's a challenging task, and it's, yeah, it would be almost impossible for us to try to list every local legislation and then try to make that keep that up to date in some way. And so it's a difficult one to do. We very much have to rely on local training providers to tackle any particular local issues that will arise where they are. And that is a challenge that they will need to tackle.
Okay, Thomas, you have 3 minutes and questions keep popping. Should we suggest that they respond to the email we're going to send that will have your email in there, or otherwise, if they have compliance specific questions, to reach out to Zendesk?
Yes, absolutely. So they have two options via the website. You know, they've got the Zendesk kind of inquiries function. Those will eventually reach me. So it's all going to come to me eventually, and then I'll pass it on to somebody else, hopefully. But they can send questions to info at globalwindorganization.org. Apologies, that's not right, isn't it not? It's Global Wind Safety.
Yeah.
That's the mistake. Global Wind Safety. Yeah. So that's the correct email. Info at globalwindsafety.org, just general information, and questions can go there. They will get passed along to me. And then if I need technical support, I'll be reaching out to the HV experts in the work group for more support. The Zendesk inquiries function is available there. And if anybody has my email address, I think, is on the website and the project page as well. So they can also reach out to me, which is just TR@, Global Wind Safety. I would advise the best thing to do is contact info, because then it gets allocated. And if I'm busy off on a work group for a week, I may not look at emails for a week. And so info will make sure that you get an answer quickly, and it will eventually come from somebody, if not me, some of the team. So yeah, all questions are welcome. There's a frequently asked questions page on the website. The standard is available for download, and then you can always come to us and ask questions as well. We have a second webinar, 23rd of July. We will cover the same topics, but there may be different questions that come up at that webinar.
Perfect.
Okay, the last thing I'll cover before we wrap up. Virginia has been working really hard organizing this event. So we have our GWO Safety and Training Forum in Madrid in October, the 7th and 8th of October, a 2-day event. It'll be a fantastic event. We'll have some interesting guest speakers. We would love to see you there. And so if you're a training provider in the GWO community, if you're considering becoming a provider, if you're one of our member companies, or if you're working in industry or considering it, there'll be lots of interesting stuff being covered in our safety and training forum. We would love to see you there in Madrid in October. And so you can follow the QR code, and that'll bring you to some more information about that event. Anything you want to add on that before we wrap up, Virginia?
I think not. I think that's very much everything, and it's really the place to meet the rest of the community and ask the questions. So we are very open to seeing all of you and bringing your questions and really suggestions. It's very much an open space.
Excellent. Okay, so I'll just say thank you to Andrew and Andrew for joining us. Really appreciated the support, and thank you to everybody that's joined the session today. And thanks to you, Virginia, for setting it all up. Okay, folks. So that's us.
No, thank you very much.
Cheers. Bye now.
Bye.